In this video, we are going to look at formula substitution, which means that we're looking at how you substitute numbers into equations or expressions. So let's first look at algebraic expressions. So if I have this algebraic expression here, and I know that x is 2 and y is 3, then we can solve this out. So the first thing I'm going to do is just put the numbers in. I'm going to substitute our numbers into our algebraic expression. So wherever there's an x, I'm going to put a 2. Now because the x here is squared, I'm going to put the 2 in brackets. Y is 3. Okay, so wherever there was an x, I put a 2, and wherever there was a y, I put a 3. And you'll notice that I put them in brackets because when we have something like 4y, what we're really saying is 4 times y. So it wouldn't make sense for me to write 43. What it's saying is 4 times the value of y, which we know is 3. So that's why I've put them into brackets. Now I'm going to use my order of operations, or BEDMAS, in order to solve this equation. So the first thing in our BEDMAS equation is the b, or brackets. So I need to solve the bit that's inside of this my big square brackets there. And inside of that, I have an exponent. So I'm going to solve that first. So I'm writing everything else out. And I'm going to solve my exponent. So 2 squared is 4. Now inside of my brackets, I have a multiplication. I'm going to do that next. So I copy everything else out. And now I'm going to replace 4 times 3 with its answer. So 4 times 3 there is 12. And now I can solve the addition inside of my bracket. And 4 plus 12 is 16. So now I have nothing else to solve inside of my bracket. I've got no more exponents. I don't have division, but I do have multiplication. So let's do our multiplications. So 2 times 16 is 32. And that is subtracting a 3 times 3, which is 9. And now I can do my subtraction, which would be 23. So my final answer there is 23. So we're substituting our numbers into the formula and then using order of operations in order to solve that formula out. So here is another one for you. I would like you to pause the video, try this one out, and then start it up again when you're ready. Okay, so our first step is to substitute our numbers into our expression there. So my x is 10 and my y is 4. Now when we have this fraction, remember that we can think of this fraction as a divide. And so we're going to solve the top and the bottom as their own equations, and then we're going to divide their answers. So on the top, I don't have anything to solve inside of brackets. I don't have any exponents, but I do have some multiplication. So let's do our multiplications. So 3 times 10 times 4 is 120. And 3 times 10 is 30. And now on the bottom, again, I don't have anything to solve inside of brackets. I don't have any exponents, but I do have a multiplication. So we're going to do that multiplication. 2 times 4 is 8. And now both on the top and the bottom, I only have addition, so I'm going to do that. So 120 plus 30 is 150. And on the bottom, I have 12. And finally, we can do our division there, which we get as 12.5 or 12 and a half. Again, here's another one for you to try. Pause the video and start it up again when you're ready. Okay, so our first step is to substitute in our numbers. So x is 3 and y is 5. And now I'm going to go through my order of operations. Again, we're treating the top and the bottom as their own separate questions, and then we can divide their answers. So here I don't have anything to solve inside of brackets on the top, but I do have an exponent. So let's solve that first. 3 squared is going to be 9. And on the bottom, I don't have any brackets and I also don't have any exponents. So for this step, I'm just going to leave it as is. Okay, now looking at the top and the bottom, I don't have anything to solve inside of brackets. I don't have any exponents, but I do have some multiplication. So let's solve all the multiplications. So I have 3 times 9 times 5, which is 135, plus 4 times 5, which is 20, 3 times 3, which is 9, minus 2 times 5, which is 10. And now I can add the top and do the subtraction on the bottom. So I have 155 over negative 1, which equals out to negative 155. Okay, now that you have the skill of actually substituting them in and solving using our order of operations, you can solve any formula you're given because the process is the same. So if you have any formula, even if you've never seen that formula before, the steps are the same. You're going to substitute in what you know and solve for what you don't know. So for example, the IV flow rate, which they put as Y, a capital Y, in drops per minute, so the unit of Y is GTTS/minute, so drops per minute, is calculated using the following formula. So the IV flow rate equals volume over time times the drop factor. So there is our formula. If you want to simplify it, just like our algebra ones up top, you could think of this as Y equals V over T times D for drop factor, if we want to kind of just simplify it to make it look a little bit better to our eyes. So volume over time times the drop factor. And then it's given us the things that we know. So it says calculate the IV flow rate for 250 milliliters of 0.5% dextrose to be administered over 180 minutes. The infusion set has a drop factor of 30 GTTS, or drops per milliliter. So let's look at what we know. Well, we know that the volume, or our V, is 250 milliliters. We know that our time is 180 minutes. And our drop factor is 30 drops per milliliter. Okay? And by knowing what we want to substitute in, we can know that we kind of need to ignore this number here. The medication in this formula doesn't matter. It doesn't matter what medication it is or what strength it is. In order to calculate the flow rate, all we care about is the volume, the time, and the drop factor. And now I can solve for Y, or our flow rate, by just substituting it into our formula. So my Y equals volume, which is 250, over time, which is 180, times the drop factor, which is 30. And now we've taken a formula which maybe looks a little bit confusing. We've never seen it before, which can bring up maybe a bit of anxiety. but we can take it and really simplify it down into basically what we did here, which is just an algebraic expression that we're substituting numbers in. And now I can solve using my order of operations. So the first thing I'm going to do here is that division, the 250 divided by 180. So 250 divided by 180 is 1.38 repeated, so 1.3888888 times 30. Now, if you are in the middle of a math equation, we never round until the very end. So you're going to keep that number on your calculator or keep it as a fraction to be the most accurate. And now we're going to do the times 30. And we get 41.6 repeated. And IV flow rate is drops per minute, or GTTS/minutes. So again, no matter what formula you have, you can take what you know and substitute it into the formula and solve using your order of operations. Okay, so I want you to try this one. We've looked at dosage calculations in a previous video, but now I'm having you actually calculate the body surface area. So some medications are given on body surface area. And so here's the two formulas depending on whether you are using the metric system or the imperial system. And what the question says is a physician orders haloperidol 1.5 milligrams per meter squared body surface area. So body surface area is in meters squared. Remember that PO means by mouth. BID means twice a day. For a patient with severe schizophrenia, how many milliliters of oral suspension will the patient receive per dose if he is 170 centimeters tall, weighs 84.8 kilograms, and the concentration on hand is 2 milligrams per milliliter? So it's using our formula substitution and then some of our dosage calculations and metric conversions we did previously. But I want you to give this one a go, pause the video, and then start it up again when you're ready. Okay, so the first thing that we need to do is with dosage calculations is figuring out, well, how much per dose? And in this particular question, the dosage is given based on their body surface area. So I need to figure out this patient's body surface area. Now we're given 170 centimeters and their weight in kilograms. So I'm going to use this first formula here, which uses centimeters and kilograms. So their body surface area equals the weight in kilograms, so 84.8, times the height, 170, over 3600. And now I'm going to use my order of operations to solve. So the first thing I need to do, we can think of the square root almost like a bracket. We need to solve under the square root first before we actually square root our answer. And so under the square root, I see that I have to do a multiplication on the top before I can do the division between the top and the bottom. So I'm going to do 84.8 times 170, which is 14416. And now I can do my division. And it's 4.00444, so 4 repeated. Again, remember, we don't round until the very end. So I'm going to keep that number on my calculator, and I'm now going to square root it. And I get 2.00111, and so on meters squared. Again, we're keeping that number because we need to use it in a calculation. So I don't want to round that number. I want to keep as many decimals as I can to be as accurate as possible. Okay, so now we can reread the question now that we know the body surface area of the patient. It's asking me what dose they will receive, and it's asking me how many milliliters. So how many milliliters of dose? So first I need to figure out, well, how much of the medication does this patient need, and therefore how many milliliters do we need to give them in order for them to get that many milligrams? So the physician orders 1.5 milligrams per meters squared. So if I have a body surface area of 2.00111 so on meters squared, and I multiply that by 1.5 milligrams per meter squared, then my meters squared can cancel and I'm left with milligrams. So essentially I'm going to times that body surface area by 1.5 and we get 3.0016 and so on milligrams. So that's how many milligrams this patient will need each dose. Now the concentration that we have on hand is 2 milligrams per milliliter. So if I take my milligrams and I'm going to times that by 2 milligrams on the bottom with 1 milliliter on the top. So I've put it on the bottom here so that my milligrams can cancel. And if you don't remember how to do these conversions, you have to go back to our conversion video. And so that shows me that I need to divide by 2 in order to figure out the milliliters, which logically makes sense, right? If they need just over 3 milligrams and it's 2 milligrams each milliliter, then I need to divide by 2. Again, I haven't rounded my answer yet. I'm keeping it the full number as much as possible. And I get 1.5008 and so on milliliters. And so now I'm at the end. I can round my answer. In this case, I'm going to round to 1.5 milliliters for this particular patient. So therefore, this patient needs to take 1.5 milliliters per dose. And of course, from this, we're then checking a few things. We need to check that that rounding is appropriate according to our medical rounding rules, that it's no more than a 10% variation of what's been ordered. Then from here, we can also calculate, well, how much do they need per day based on the fact that they're taking it twice a day. And I can also then check, okay, if they need a 10-day supply, how much am I supplying them with to fulfill a prescription and so on. So you can continue this type of question to figure out actually administering this medication then. Okay, so what I'd like you to do is now rate yourself, reflect on how you've done with this video, giving yourself a thumbs down if you're having trouble with formula substitution, so being able to take a number and substitute it into a formula or algebraic expression and solve using order of operations. Are you having trouble with that and you need some help? Do you need more practice? Or I can do this, I can solve formulas using substitution and I don't need any more help or practice.